This is a project on skin cancer detection using machine learning. We are Team 44. A motivation for this project comes from skin cancer being the most common group of cancer diagnosed worldwide, with more than 1.5 million new cases estimated in 2022. And the early detection of these type of cancers is very important. The cost of detecting the skin cancer without insurance typically ranges from $100 to $300, depending on the location and healthcare provider. So, we are trying to build a model on CNN to detect this classification of skin cancer type to help this further process. A data set is a huge collection of multi-source dermatoscopic images of pigmented lesions. There are about more than 10,000 unique images, and depending on that, we have labels of these different type of cancers and the gender, age, localization, and patient history. For further data information, the model architecture with CNN, which contains bunch of conv2D, max pooling, batch normalization, and dense layers. The conv2D is a convolution 2D layer which creates a kernel which produces a tensor of outputs. In our model, it creates 32 filters in convolution and the kernel size is typically 3 by 3. The max 2D layer performs max pooling operation for spatial data, which is a way to reduce the dimensionality of the input by downsampling the input. This helps the model to generalize better. The batch normalization layer normalizes the activation of the previous layers at each batch. And finally, we have the dense layers, which regular densely connected neural network layer. It implements an operation of output of activation. In our model, it has 256 units. And we have dropout layer. This layer randomly sets input units to 0 with a frequency of rate at each sampling step during training time. This helps preventing overfitting. And we have at the end about two dense layers and the final dense layer with 7 units, which corresponds to a 7 label of output classes of type of skin cancers. As described in our model architecture, this is the process of training. We have 10,000 of image data as our input layer, which passes through convolution layers, then to pooling layers, and then finally the fully connected layer at the end, producing 7 different outputs of different types of skin cancers. This is the comparison of a baseline model versus our model of training accuracy and test accuracy. Baseline model, we were able to achieve around 96% of training accuracy and around 65% of testing accuracy. But after introducing our model, we were able to achieve training accuracy of nearly 100% at around 99.8%, and our testing accuracy increased to around 75%. You can see our model accuracy versus the baseline model accuracy here, where our model accuracy reached at around 100% at the end, and our validation accuracy is always above 80% compared to a baseline accuracy of around 70%. Is our baseline model with corresponding skin cancer images to the label in our metadata with an accuracy of 65% versus our model results with corresponding images and the labels of type of skin cancer with around 76% of accuracy. Thank you.